Okay, so this is the starting. So introduction of civil engineering. So mainly this is theory part, but I would try. So first start this the branch. Okay, the branch knowledge which deals with the various industrial process. It defines its technology. Then this is the what is civil engineering. Definition of civil engineering is called the general engineering because civil engineering uses the principle and information provided by other branches. Okay, and that's the thing. Okay, what is surveying? The study of surveying enables an engineer to determine the relative positions of point on the surface of earth. Okay, and leveling is the process to determine the vertical positions of the different position of different points below on or above it. Okay, I would do it above. Okay, I would do it later. And underlined part is not and no, it's not explained by sir also, and I haven't seen any paper also, but it's given just read it once. Do not write it on the notes. Okay, just write the highlighted parts. Okay, now this is the general classification and class classification based on purpose of surveying and classification based on instrument used for surveying. Then this the purpose of surveying is important. Okay, surveying is necessary for preparing the plans which are projection. Okay, this 2 point highlighted one is important. Okay, after that fluid mechanics and hydraulics is it's usually the water, how the water, it's branch of science which study the fluids at rest and in motion is done. Okay, just create just try to create your own definition. It would be helpful in exam also. Okay, I have highlighted some points. Okay, but okay, wait, it's not necessary these two things to write. Okay, okay, this can be underlined also. Okay, yes. So highlighted parts only. Okay, here the knowledge of force exerted by the water is useful in design of the gates used to control the flood water in case of dams. Okay, now transport engineering is subjects deal with the transport of men. Okay, it's mainly the transport work done. Okay, the highlighted part is enough. Okay, then underline you have to just read it. Okay, okay. Now water resources engineering can be defined as a science which deal with the subject of tapping water. Okay, so there are two water things. One is water resource engineering, and what one is hydraulic fluid mechanics. The difference between is that hydraulics is work on that how to use water energy like water on the dam and water in the river. Okay, to benefit in our daily life. Okay, like dams, we use water resources. Sorry, river water to um, or seawater to get an electricity from it. Okay, water resources engineering are how to protect water resources like groundwater. Okay, rainwater, how to store, how to uh, reserve, how to protect that clean water for our use by technology. Okay, environmental engineering is also right the highlighted part only, and in environmental engineering is that it should not harm the environment. That's how to do that. That's only it was. Okay, and uh, environment is how to protect environment mainly. Okay, so it's mainly it contain all things. Geotechnical engineering is okay, soil mechanics. It's mainly about soil, how the soil, what's quality of soil. Okay, mainly the study of soil are is known as geotechnical engineering. Okay, foundation engineering is something like how to what you know that every house has a foundation. Okay, so how to build a foundation. Okay, to stand the building, like how the foundation was done. to stand the highest building, the Burj Khalifa. In the so it's required a huge mechanics and civil engineering. So that's we involve foundation engineering. In the course, there is no foundation engineering, but just for information, you should write it. Okay, I suggest you should write it. I just highlight it. Okay, okay, yeah, okay, and not this color. Yeah, okay, just okay. Oh yes. Okay, this match is okay. And construction technology, building technology, how the building is created, like how to keep the bricks on the wall, how to do the things, how to apply, how to attach door, how to attach windows. These are involved in construction technology, or you can say building technology. Both are same thing. In that, right, this one, this one, this highlighted point, then these two highlighted point, and this point. Okay, if you want to then create an additional, okay, create an additional what I say note. In note you can write this: the scope of construction is more comprehensive here than that in building technology. Okay, okay. In note you should write this. Okay, and in note only you should, I think I should you should write this also, but it's your choice here. Now building material, it's important like parts. I have not highlighted it. Okay. So building material you should write this, and some of the building material are brick, stone, aggregate, cement, alternative building materials, composite material, and smart materials. Okay, so brick, you know what it is. Stone is, you know what it is. Aggregates are, you can say, one of the aggregates is tar. Okay, the when you have, and if anyone has seen the when the roads are created. Okay, so there is a black sticky things used in it. It's a tar, or I don't know what's its English name. Okay, so it's a aggregate. Okay, cement, you know what is cement. Then alternating building materials are like pipe, and there are some places where we can't use bricks, and many other places. Okay, sometimes we use iron only. Okay, so these are alternative building materials. Okay, okay, we use some in Jammu Kashmir, in cold areas. There we use, there most of some houses are made of wood to protect, because it's a good conductor insulator. Okay, so it would stop heat from passing out, and cold airs to pass in. So how wood can be used as alternative building materials. Okay, composite material are like glass of our windows. Okay, and what are the things, some plastic things. Okay, in switchboard, those are also in uh, civil engineering also only. So we use composite materials too. Smart materials are like Alexa. Today most of the Alexa can open the door also. So it's are like smart materials. Okay, infrastructure development. So infrastructural facilities make a topic. Okay, and then write these facilities such as transportation, energy, and this is infrastructure facilities. Then impact, or effect of effect. Write the effect. Okay, write it at effect of infrastructural development on the country. Okay, so effect of infrastructural development on the country. Write this to 6 8. Okay, it's 8 points. Okay, if you read once, you would understand what are the infrastructural development. I don't. Okay, so should I read? Increase in food production. Okay, like factories, protection from famine. I don't know what is famine. Save domestic industrial water supply. Okay, okay, yes, water supply, because what if industry would grow, then uh, there are chances that acid that acid water which is released from industry would also be made it clean before releasing it. Improvement in communication and transportation. In communication, 5G is going to launch, and transportation, that is e-tag, fast tag, it's launched. Hard generation of hydroelectric dams. Okay, addition to wealth of the country. Yes, it's okay. Increase in prosperity of people. Yes, if like America has a city square, it's the most advanced thing. So the people there are also, we most of the people think they are advanced, but nothing such that. Okay, overall development of the country. Okay, rule of civil engineers. Okay, so these are the 13th rule. Mainly in exam, if you write 10 also you would get full marks. Okay, so you have to run this, sorry, learn this, not run. Okay, then this roads and highway. Okay, I just deleted it in what I have said. Okay, so because it's not in the new course, and the book is of 14 to 18 syllabus. Okay, but it contains everything of 18 syllabus. Actually, the new syllabus has most of some of the parts removed. Okay, so bridges and roads, bridges are not in our course, but still sir had taught us. Okay, so what I would do, I would just send the photo of what the road and bridges sir have taught. Just write it and just read it. But I don't think it would be coming in exam, because from 2 year there is no question from roads and bridges and dams in question paper. Okay, so I am not going to study it. Okay, it's your choice. You can study. Okay, now main chapter 2. Okay, the main part start from here. The particle. Okay, a particle is a, okay. So, oh, okay. So, okay. So, a particle is this. Okay, this is a particle. Okay, this is the particle. Okay, what is the definition of particle? Is a particle of a infinitely small volume whose mass can be neglected is called a particle. Okay, so yes, it's a very infinitely small, and its mass can also be detected. Okay, now a body, the assemblage of the number of particles. I would okay, is known as the body. Okay, so a body is like, if it is the rod. Oh, what a rod! It should look like baseball bat. Okay, so if this is the body, so it must have a very small particle. Okay, jointed. Okay, so this is a body. Okay, actually these are the things. Okay, now just first read rigid body. A rigid body is one in which the position of the constant particle do not change under the application of external force. Deformable body. A deformable body is one in which the position of the constant particles change under the application of external force. Okay, now what it is, like there is a body. This is body A. This is body B. Okay, body B, body A. Okay, now there is some amount of force applied on both the bodies. Okay, this can be any amount, very less, also very hard. Now this body, it doesn't change its shape or size or anything. Okay, so the body is a rigid body. Okay, but the body B change its shape. Okay, it can be a high force or low force, but the body B changes its force, sorry, shape. Okay, then shape or size, then the body is deformable. Okay, now there is a one thing, continuum. Okay, yes, continuum. A continuous distribution of molecules in a body without intermolecular space is called continuum. Okay, so what is a continuum? Continuum is a from infinity to infinity going object. Okay, it's go from infinity here also, and it's go from infinity here also. Okay, wait, Yes, both side it goes to infinity. Now difference between this is a continuum and this is a body. Okay, both both are same thing, but how it's different is a continuum is from infinity to infinity. Okay, it doesn't have a fixed definite length, but it is of infinity size. But body has a definite size. Okay, and a body is water that if in body if this is a molecules, okay, and this is another molecule. Now if you attach third molecule, okay, here it is. So so here see, here somehow the space is left. Okay, but what happened in continuum? uh, it's an imaginary thing, but it's continuum that when molecules are attached, there are no intermolecular space between them. Okay, there is no intermolecular space between them. So its main difference is this is continuum. Just remember the definition. It's not going to ask an exam. I mean, it's going to ask an exam the definition thing, not any question on it. Okay. Now Newton's laws of motion. So Newton's laws of motion are, you know what are the Newton's laws of motion? The first one is that inertia one, that till the inertia would be same always. Second one is the change of momentum, that F is equal to ma. And third one is law of action, and law of action is equal to law of, sorry, action is equal to reaction. Okay, so it would be used in okay, let me explain one thing. Okay, I think I should explain this. Okay, so according to first law, okay, this is a body. Okay, and it's in rest. Okay, so until there is an external force acting on it, F or anything, it would be at rest. And let's assume that if it was in motion, okay, then if no external force would be applied to in opposite direction of it, its motion would not be stopped. Okay, it would be continuously in motion. That's the first law of motion. Okay, second is when a body is covering a body of mass m, okay, is traveling with acceleration a. Okay, actually it's momentum term, but for I'm understanding, I am just saying, then the force applied on the body is m is equal to a, m into a, sorry, m into a. Okay, just this is the result of the uh, second equation, second law of motion. Okay, but actually it is that the it is initial rate of change of momentum. Okay, so momentum is actually not in our course, so I'm not explaining it. But what it is first of all, its velocity was anything v1. Okay, and after some time, its velocity would become v2. Okay, and the mass was m2, m. So the rate of change. So rate of change is m v2. Okay, minus m v1. Okay, upon rate of change is equal to time. Then if you take m common, then m would become common, and minus v1. This would be equal to force. This is the force applied. Rate of change of momentum is equal to force applied on the body. So this is the acceleration formula. Final velocity minus initial velocity upon time taken. So this is the acceleration. So we got this. Okay. And this is also a formula of F. Just we have taken m common. Okay. Now third is, okay. Let me change the color first. I don't like lal cool. Okay. So third is, if this is a body, okay, a force is applied. Let it be F. Okay. at this point, at this point a force is applied, F, which is equal to F, then equal and just opposite. Like if it's vertically downward, then it would be vertically upward. Force acting on the at that point only by body, which would whose magnitude would be equal to F. This is equation third. Sorry, law of motion. Uh, Newton's law of third. Listen, third law of motion. Okay. Now this is something you should have to remember. Force is it is an external agency. Its agent. Okay. Force is an external agent which tend to change the state, shape, size, and speed of a body or a particle. Okay, this the SI unit of force is Newton, and now the characteristic of force. The force can be identified with the four character magnitude. Okay, the length of the vector represents the magnitude of the force. Okay, so this is the length. So this is its magnitude. Its direction is to this side. Okay, its direction is to this side. Okay, line of action is its x-axis. So we would say its line of action is parallel to x-axis, and point of application is where this. Okay, if I draw a body here, so the point of application is this. Okay, the point of application is this. Now, point force is like it's the body and the force is acting at this point only, so it's point force. But if the point force would be acting at whole this side, at this whole thing, then it should not be point force. It would be many forces acting on it. Okay, now force system. Okay, so force system is this definition is not important now. Mainly there is types of force system. So there are 8 types. Okay, you just have to remember that coplanar co-current force system. What is coplanar co-current force system is if two or more forces are acting in single plane. Okay, coplanar means single plane. Okay, and concurrent means they are passing through one point. All the lines are passing through one point. So and their lines of action pass through a single point. This is the line of their action. Okay, F1, F2, these all passes through this point. So it's coplanar. So we can say that F1, F2, F3, and F4 are coplanar, co-concurrent force system. Okay, and similarly, if these if the force, these four forces would not pass to same point, then we would not say it's a. It would say we would say F1. Okay, let me see. F if two or more forces are acting in single plane and the line of action do not meet at common point, then the force constitute a coplanar non-concurrent force system. Okay, see, their line of action are different, so they are non-concurrent. Sorry, yes, non-concurrent, concurrent. Okay, and parallel force system. You should understand that the force of action forces are parallelly. The book have given an extra too that they are like parallel force system and like, but it's not in the course. So just write this and draw any of the two diagram. Okay, now if two or more forces are okay, sorry, no, non-coplanar directly we should go. Okay, so if a system has two more force acting on a different plane but pass through the same point, then it's said to be non-coplanar concurrent force system. Okay, so it's 3D box and forces are passing through one point, so it's uh, non-coplanar concurrent force system. It's non-coplanar because it's not in one plane. Okay, now non-coplanar non-concurrent force system is it's not acting in a single plane and it's not passing through single point also. Then no non-coplanar and non-concurrent force system. Okay, and similarly non-coplanar parallel is it's uh, not in the same plane but parallel to each other, like f1 f2 are parallel, f3 f4 are parallel. Okay, and actually f1 and f5 are parallel. Okay, f3 and f8 would be parallel, so it's a non-co-parallel. planar parallel force system. Okay, now collinear force system. If the lines of action of two or more forces coincide with one another, it is called collinear force system. Okay, so you can see these are all in one line, so it's collinear. And these all are not in one line, so it's not collinear. They do not coincide with one another. Line of action is not coinciding, because here you see it's coinciding, but line of action are different. So these are non-collinear. Okay. Now, okay, these three. Okay. So, okay, okay, okay. So first of all, principle of transmissibility of forces. This principle states that the state of rest or uniform motion of a rigid body is unaltered if point of the application is transmitted to any other point along the same line of application. It says that let it be a body. Okay, let me create a white body. Okay, okay, okay. It says it is me. Okay, sorry, let's create again. Okay. Oh, okay. So this is the body. Okay, it can be on rest or motion. Okay, and a force is acting. Okay, on. Oh, sorry. Wait a second. I will just erase this and okay now. Its line of action is this. Okay, it's this is the line of action of force. Okay, and this is the force. Okay, okay, it's F. Okay, and now it can body can be on rest or in motion. Okay, now if we remove that force from here and in the same line of action with the same force we apply at this side. Okay, and okay, we have removed this force. Okay, we have removed this force from here, and we have in the same line of action we have applied the same force on another point. Okay, in the same direction only. So now the body would change in state, like it if it was in rest, then it would still be on rest, and if it was in motion, then it would not change its velocity or acceleration. It would just be the same. Okay, this is the principle of transmissibility. Okay, now just in okay, now state superposition is okay. So this is the body, okay, of anything. Okay, now there are three forces acting on it. Okay. One is F1. Okay, okay, this is F1. Name it F1. Okay, this is F2. Okay, and this is F3. Okay, now what is wait a minute, I should just once review all the principle. So this principle states that the net effect of the system of forces on a body is same as that of the combined effect of individual forces on the body. Okay, now what it says that this is the acting force on the body. So uh, force acting by F2, force acting by F1, and force acting by F3 is equal to a equivalent force which is R. Okay, so body is having F3 in this direction. Okay, wait, just yes. Now body F3 is in this direction. Okay, F2 is in this direction. F1 is in this direction. Okay, so and resultant is in this direction. So superposition is, or you can solve these three forces uh, in what we say simultaneously, or you can just make a resultant of these three forces and just solve that. Okay, so this is the principle super what it was something. Okay, wait, let me know. Superposition of forces. Okay, okay. Now physical of okay, it does not have any diagram. You can draw this diagram and write it there. Okay, let me write. Okay, okay, okay. Okay, I would write it with green one. Okay, so you can write it after this. R is equal to F1 plus F2, okay, plus F3. Okay, I am seeing it. Okay, just write it. Okay, 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 yes. Okay, so draw this diagram and write this formula. This principle of superposition of forces. Okay, after this principle, because and transmissibility also, if you just if you don't want to draw this, you can draw the previous one. If you have drawn this one, then no problem. And you haven't drawn it, so draw it. The previous one, just reverse the video, and you would find that what I have drawn. Similarly, you can draw it. Okay. Now the principle of physical independence of forces. This principle states that the action of a force on a body is not affected by action of any other forces on the body. Okay. So for this, we don't need. I just don't need this. Just this diagram is can be done. Okay. 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 So we don't know. We don't want this to. So okay. Okay. So according to its principle of independence is F1, the force acting by F1 on the body is independent of F2 and F3. So the whole force would be acting on the body and there will be no effect of F2 on F1. Like if we are applying a force from, if I am pushing from this side and someone is pushing from this side, so there would be no effect from that person to my force. Okay, I am pulling with my full force. If he is pulled from this side, so the body would just move from this side, okay, to this side. Okay, okay. Then if he, I am pulling from this side and he is pushing from this side, okay, so just the body would move to this side. Okay, to just move to this side, it would not because he is this side, he is applying for this side and I am pushing this side, so the body would turn this side or any side it would turn. Okay, so it would just turn, we would have fully. Okay, I want to say just forces are independent, like our independently a person can do what he wants. So and if nobody uh, if someone is saying just ignore him, do our work, that similar is force. If someone is applying his own force, don't worry of him, just do your force. Okay, just draw your force. Okay, if you want it diagram, just remove the, I'm just removing the yellow one part. Okay, just you can draw the, okay, just you can draw this and write F1, F2 and I'm speaking again. F1, F2 and F3 are independent forces. Okay, just this is all clear. This would be clear now. Resolution of forces. Okay, 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 okay. So it's just simple. See. this is f, this is the, it's a rectangle. Okay, so it's angle d is 90 degree. Angle, okay, so angle d is 90 degree. Okay, and here it's 90 degree. Here it's 90 degree, and fx it's fy. Okay, by using trigonometry. Okay, just this has given that fx value is f cos theta and fy value is f sin theta. This is theta and trigonometry, that cos theta is equal to base upon this base. Okay, this is base and this is hypotenuse. Okay, this is b and this is h, and this would be p and this would be h. So p upon h sin theta and b upon h would be cos theta. Okay, and this is fy is equal to f cos theta comma fx is equal to f sin theta. Okay, and just it's same. Okay, now composition of forces is okay. Okay, so resolution of forces is this. Okay, the process of splitting force into two rectangular components is known as the resolution of force. Okay, and just draw the diagram, and these two line would be enough. Just, and I don't think this is important. It's just written above also. Okay, yes. Okay, now composition of forces. It's the process of combining number of forces into single force. That the resultant one above I have fold the diagram. Okay, the superposition of force. That only the how to sum of the how to find the resultant force. Okay, so just you can learn that r is equal to f1 plus f2 f3. Okay, just I would suggest just write this. Okay, just write this. Okay, and you would understand this question, this thing by in question only, but I would try to okay, I just can't draw on this. Okay, clear all. I just wait. I just oh, okay, okay. I just save. Where is the save? Okay, yes. Okay. So this is the body. Okay. This is the shape. Okay. 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 This is F1. Okay. Let me create another one. Yeah, yeah, yeah. So okay. Now and okay. I just now oh format. Okay. Now okay. So okay. Okay. This is yes. This is okay. Now just okay. So actually it's theta angle. Okay. So this is fx and matlab, I want to say that this direction is the force constant would be the fx and this would be fy. So now, okay, so just reverse the direction, yeah. Okay, this is in opposite direction. It would just make everything okay. Not a problem. Okay, so wait, exit. Okay, oh no, no, it's okay. So okay, so it's this value would be oh, okay, okay, okay. This value would be this is all are f. This is also f. Okay, this is also f, and this is also f. So f sine theta. Okay, this would be f sine theta from trigonometry, and from this point to this point would be f cos theta. Okay, I would explain it in the copy. I think. Okay, so I would just okay, okay, yes. I would explain it, just write it as this thing in the notes, okay. And I would explain it when we would do the questions. I would do it. Okay. Now I want to just ask that if everyone know the parallelogram law of vector addition, and you know the parallelogram and triangle and the polygon law of vector addition. You should have 12 in studied in 11th, that these are the two vectors. Okay. Then we create and a parallelogram of it. Then we extend the line B to E. Then we just join it CE. Then from trigonometry using, just read this. Okay, you would understand what it is. Okay, just read it and just see once the diagram. You would understand what it is because you know what it is. You have learned it. You have studied it in 11th and it was used till 12th also. And in engineering exams also it was used. So you know what it is. You just once have to revise it. Okay, just read it once. I don't want to just waste my time. I don't mine. Mean to say that I just don't want to revise it again. You know the thing. You know what? It's no need to explain you again. Okay. Okay. The moment of force. Okay. The transition. Okay. So what is moment of force? This is the point of action. If diagram drawn. Okay. This is the origin. Now this is the force. Okay. And this is the perpendicular distance between it and this. Okay. Now. Okay. Now magnitude of force is F and this perpendicular distance is R. Okay, it's R. Okay, so according to moment of forces, the turning effect of the produced by force is known as moment of force. The magnitude of the moment is given by the product of magnitude of force and perpendicular distance between the line of action of force and the point of axis of rotation. Okay, so this is the point of action of rotation. This is the line of action. Okay, this is the line of action and the axis perpendicular distance. So the moment of force is okay. Moment of force is F into X. Sorry, R. The R. Yes. Okay. And it's in clock. It would move in clockwise direction because if this is the door, and if you apply force this side, okay, so the door would be from this side to become this side, like this it would rotate. So this is clockwise. And if we apply to this side, then would be this side, then this side, then this side, this side. So when we apply, when the door moves in, this is the clockwise direction. So we name it as the clockwise moment of force. And when the due to force the motion move in anti-clockwise direction, so we call it anti-clockwise clockwise moment of force. You can see it in here. A clockwise movement is when we move in clockwise movement. Okay, this tendency of force is rotate the body in clockwise direction. It is said to be clockwise movement. And if the tendency of force is rotate the body in anti-clockwise direction, it is said to be anti-clockwise movement. Okay. Okay, Varigon's theorem is I am going to explain on the paper. So after the video, I would just upload another video. I would record it by phone on the copy, and then I would send it. Okay, it's okay. I would explain there only what it is. Okay, now couple, it's not a huge thing. Most of the questions are not coming from here. Okay, so just relax and just you have to learn thing. Okay, so it's two opposite and two equal and opposite and parallel force constitute a couple. Okay, so actually what it is, it's wait, I would just draw this also on here. Okay. Oh, okay. Now this is the oh, fuck. Okay, this is the now I'm going. Okay, this is a point. Okay, point of action. What I taught in for that. Okay, now these are okay. So this is okay. Both the direction is x. Okay, value of direction. Sorry, the perpendicular length is x. Okay, now a force of magnitude F is applied this side. Okay, and another force is this is upward and this is downward. Okay, and both magnitude is F. Then it is known as couple. If two forces are acting from equal distance in opposite direction from a point, then at that point a couple of force F is acting. Okay, so this is the same, and just draw its here a point. Okay, and name is point of action. Okay, it's not in the diagram. Okay, and the properties of couple, just and types of couple. Clockwise couple, you should know, you understood with the clockwise and anti-clockwise couple. Clockwise is when this would rotate is in clockwise, because see, if there is a scale and you rotate it in clockwise direction, one is we applied upward force on one side and downward force in one side, then it would be clockwise, and vice versa it would be in anti-clockwise. That's the same. Okay, so I'm going to upload another video of this Varigon's theorem. Okay, and after that on Tuesday we would be starting the numericals. Okay, and till now this mechanics part is important, just to go through it once. Okay, in the book also. And couple is you have to write it that it is, and I would send the Varigan's theorem of moment theory. Okay, and moment of force you can write this and just draw this diagram. If you want, you can also write this clockwise movement and anti-clockwise movement if you want. As wait a minute, this is important. Okay, this is important. You have to write it. Okay, yes. Okay, that's all. I am just going to record that Varigan's theorem of movement. Okay. just this time it